Now let's learn to go the other way. So if we have a rectangular equation, how do we go from that form into a set of parametric equations that are equivalent? Well, in fact, it's really not that difficult. One easy way is just to simply choose a variable to be t. And you can pick x or y, just kind of depending on what your next steps might be. So for instance, if I chose x to be t, then I really wouldn't have to do a lot of work in order to solve for y in terms of t, because I just replace the x in the y equation with t, and that gives me an equivalent set of parametric equations. Now these parametric equations are not unique, so I could choose really anything for x. Like I could make it t minus 1, for instance. And then I could take this and plug it in for y and get y equals 2 times t minus 1 squared minus 3. And this is a perfectly valid set of parametric equations for the same relation. So there's generally an easiest way, but there's never a only way. Now sometimes there is an advantage to not just choosing something simple like t for one of the variables. You can really simplify both of your equations for choosing something a little more complex. So in this example, I could choose one of the variables to be something more complex, like, for example, this logarithm. Now notice the logarithm is of x, so I can't pick x equals the logarithm. It would need to be t is equal to the natural log of x minus 4. Then I have to do some work and actually to solve for x. It wasn't necessary in the previous example because I solved basically t equals x, or x equals t. It means the same thing. So it's a bit more complex, but it's still doable. I would need to raise both sides here as an exponent with base e. So e to the natural log of x minus 4 reduces to just x minus 4. And if I add 4 to both sides, I would have, say, 4 plus e to the t is equal to the variable x. So now I have something for x, and y is just going to be what I chose for t plugged in. So 5 plus the natural log of x minus 4 was equal to t, so I can plug that in. So I would have 5 plus t squared. So both of these equations are a bit more simple than what we started with, which is nice. Now in this last example, I'm going to take advantage of the Pythagorean identity, just like the way we did an earlier example. So the Pythagorean identity is cosine squared x plus sine squared x equals 1. Or more generally, some cosine squared plus some sine squared equals 1. Now this might take a second to sink in, but you really can do this. So I have two things squared and added, and that's equal to 1. In my equation, I really do have two things squared and added, and that's equal to 1. So what I can do is basically assume that the two things added are equal to each other. So I can say here that cosine of x is equal to the x over 3, or actually that x's don't make sense, do they? Let's change these to t's, make it parameterized. So t, t, make these t's as well, and then cosine t equals x over 3. That makes more sense. And then sine t equals y over 3. And then at this point, if I multiply, no, 2, over 2. If I multiply by these denominators, I would have 3 cosine t equals x, and 2 sine t equals y. So that I have a pair of parametric equations that represent this particular curve. And if you're unsure if that actually works, try some graphing software and graph both equations and see if you get the same result. You will need some bounds on t, so go ahead and just bound between 0 and 2 pi. You'll get the exact same picture of an ellipse. The last example here is just some additional examples for graphing on the calculator. I'm going to leave those there for you to practice with since we did some earlier in the first video.